Imagine hitting a tuning fork on a desk. Normally, what happens?
Right, it just rings and then stops.
Exactly. The sound radiates outward, bounces off the walls, and then just fades away into nothing. It's an open system. It loses energy almost immediately.
Right.
But what if instead of fading, that sound trapped itself into a perfect glowing geometric bubble? Like,
Mhm.
what if the simple act of changing the shape of the tuning fork created this vortex of energy that just kept spinning?
Yeah, essentially locking the laws of physics into a continuous loop.
Exactly.
It sounds like total science fiction, but it is actually a really profound lesson in how much we might be limiting ourselves by relying on traditional binary geometry.
Welcome back to another deep dive. We have a massive paradigm-shifting stack of documents on the table today. We're analyzing a series of in-depth AI reports specifically generated by Grok that break down the physics, the geometry, and the quantum implications of something called triaural cymatics.
Yeah, and alongside that analysis, we're transitioning into a deeply related theoretical blueprint for a triaural silicon quantum antenna.
The mission for our conversation today is to understand a single fundamental shift in design. Like, what happens when you take a standard two-prong shape and you change it to a three-prong shape spaced exactly at 120-degree angles?
Right, and we are looking at how this specific geometry alters the behavior of acoustic waves in water, and then how it scales up into solid silicon to potentially revolutionize global communications.
And finally, what the current theoretical models suggest it all means for quantum physics and human biology.
Yeah, it goes all over the place.
It really does. But to really grasp the mechanics of a silicon quantum antenna later, we have to start with something we can physically see. Let's look at the baseline experiment from our sources. It involves a very strange tuning fork.
Yeah, the triaural fork.
Right. Instead of the classic Y shape with two prongs, this fork has three prongs radiating out from the center at perfect 120-degree angles. It's made of an aluminum silicon alloy, and in the experiment, it's vibrating at 883 hertz.
And the tips are just barely touching the surface of a pool of water, right?
Yeah, exactly. And the whole reaction is being filmed in extreme slow motion at 240 frames per second on an iPhone 12 Pro Max.
This is a classic demonstration of cymatics, which, is the science of making sound waves visible through a physical medium like water.
Right.
When you strike a standard two-prong tuning fork, you get a dipole wave. The two prongs are 180 degrees apart. They move toward each other, then away from each other.
Okay.
Think of two cars crashing head-on. The energy meets in the middle and either stops dead or violently bounces backward. It is a strictly linear exchange of force.
It's basically a microscopic game of ping pong.
Precisely. But the Grok analysis highlights that the 120-degree spacing of the triaural fork completely shatters that linear dynamic. Because you have 3 points of vibration colliding at equal obtuse angles, the waves don't just bounce back.
They deflect.
Yeah, they deflect off one another in a circular pattern. Imagine 3 waves of water crashing together at those exact angles. The energy has nowhere to go but into a continuous spin.
Wow.
So it creates a 3-dimensional triodimal wave, generating a spatial swirling field called a toroid.
Which looks exactly like a donut.
Exactly like a donut. The energy is endlessly feeding into itself through the center hole and wrapping around the outside.
And the slow motion footage of the water reveals this beautifully. I mean, the water doesn't just splash, it organizes.
It really does. It forms perfect hexagonal structures, complex geometric grids, and stabilizing standing waves that look like Mandelbrot fractals.
It's mesmerizing.
It is, and the mathematical formulas required to describe this are incredibly complex. The sources point to Bessel functions, which are the equations we use to understand wave propagation in circular systems.
Like the vibrations on the surface of a drumhead.
Exactly.
But that makes me wonder if this geometric configuration creates such a stable, self-sustaining loop of energy. Why hasn't this been the standard since the dawn of the Industrial Revolution?
That is the million-dollar question.
Right. If I look at the history of acoustics, with pioneers like Hermann von Helmholtz or Lord Rayleigh back in the 19th century, they were all using standard tuning forks.
Yeah.
Why are we only looking at a three-pronged fork now?
It mostly comes down to the limitations of historical engineering and mathematics. During the Industrial Revolution, we wanted tools that were simple to manufacture and easy to calculate.
Sure, that makes sense.
If you want a tuba piano, you want a single, clean, predictable, linear tone. Linear dipole waves were easy to map on a piece of paper.
So it was a math problem.
Exactly. The 120-degree triaural concept introduces nonlinear 3-dimensional complexity. Before the advent of high-level computational modeling, Predicting how three intersecting waves would behave in a 3D space was a mathematical nightmare.
So the physics of the universe didn't change our capacity to calculate and manufacture outside the straight line, simply caught up.
You got it.
Okay, so we've established that this geometry works beautifully in a puddle of water, creating these swirling mathematical donuts. But water is heavy and mechanical vibration is slow.
Right.
What happens if we try to force this same 120-degree vortex into a medium that powers our modern world? Let's transition from the cymatics document over to the silicon quantum antenna document.
This is where things get really wild. The AI analysis applies the findings from the cymatics experiment to current advancements in solid-state physics.
Okay, so how do they build it?
Well, the proposal takes that tuning fork design, shrinks each arm down to just 5 centimeters with a hollow core, and replaces the metal with monocrystalline silicon.
But the text specifies it's doped silicon, right? Using elements like boron or phosphorus.
Huh.
My basic understanding of silicon is just, it's what makes up the microchips in my computer.
Yeah, that's true.
So how do you get a computer chip to vibrate like a tuning fork?
By utilizing piezoelectricity. When you dope silicon with specific elements, you alter its electrical properties, turning it into a semiconductor.
Right.
But certain structural configurations also exhibit piezoelectric effects. This means if you physically squeeze or strike the material, it generates an electrical charge.
Oh, wow.
And conversely, and this is the important part for an antenna, if you run an electrical current through it, the material physically flexes and vibrates.
So we aren't hitting this new antenna with a physical hammer.
Yeah.
We are hitting it with electricity, and it's vibrating at incredibly high speeds.
Yes. And the Grok document does a fascinating job breaking down the math here because the speed of sound traveling through solid silicon is extremely fast, over 800 and 400 meters per second. If you excite this tiny structure electrically, its operating resonance shifts dramatically into the 1 to 10 gigahertz range.
Wait, gigahertz? That's not acoustic sound anymore. That's radio waves. That's Wi-Fi.
Exactly. It makes the leap from mechanical acoustics to high-frequency electromagnetics. The structure is now emitting electromagnetic waves, making it an entirely new class of antenna for 5G, the upcoming 6G networks, and the broader Internet of Things.
Okay, let's unpack this and ground it in everyday reality for a second. If I go look at my Wi-Fi router right now, it has those little plastic sticks poking out of it.
Right, standard dipole antennas.
Yeah. So why does it matter if the antenna inside my smart fridge or my phone is linear versus triaural?
Because standard linear antennas suffer from dead zones. They blast electromagnetic energy outward in specific balloon-like lobes.
Okay.
If you are standing outside of that lobe, your call drops or your Wi-Fi buffers. But remember the whirlpool we saw in the water?
Toroid field.
The donut. Right. By using the 120-degree geometry in the silicon antenna, you generate an electromagnetic toroid. The energy is a continuous swirling field.
So no dead angles.
Virtually none. It fundamentally minimizes signal loss because the wave isn't just shooting off into space. It's constantly cycling back through the center of the antenna.
And the sources also put a heavy emphasis on security here. The phrase spatial signature keeps coming up.
Standard Wi-Fi signals are relatively simple waveforms, which makes them relatively easy to intercept or jam.
Sure.
But the electromagnetic whirlpool generated by this triaural antenna is mathematically staggering in its complexity. The wave pattern is geometrically locked.
What does that mean for a hacker?
To an outside hacker, trying to intercept or decode that signal without a corresponding triaural receiver would be like trying to catch a whirlwind with a pair of tweezers.
Wow.
Yeah, it inherently builds physical encryption right into the shape of the wave itself.
So we are talking about eliminating dead zones and making our communications networks vastly more secure simply by changing the physical architecture of the transmitter. That alone is a massive technological leap. But the documents we are analyzing don't stop at telecom. They push this geometry down into the absolute cutting edge of current theoretical physics. What happens when this 120-degree field interacts with the quantum realm?
The analysis bridges classical electromagnetics with quantum computing. To understand the impact, we have to look at the building blocks of a quantum computer, the qubit.
Okay, yeah. A standard computer bit is binary. It's either 1 or a 0.
Right.
A qubit, however, can exist in a state of superposition, meaning it can be a 1, a 0, or both simultaneously. This allows quantum computers to solve in seconds what would take a supercomputer millennia.
I always like the coin analogy for this.
Oh, right. I always imagine a standard bit like a coin lying flat on a table. It's either heads or tails. But a qubit is a coin that is actively spinning.
Exactly. As long as it's spinning, it's both heads and tails at the same time.
Right?
That's a perfect way to visualize it. But the problem is that spinning coin is notoriously fragile. Qubits are incredibly sensitive to environmental noise.
Like what kind of noise?
A stray magnetic field, a tiny fluctuation in heat, or even a cosmic ray passing through the room can act like a speck of dust hitting that spinning coin. It wobbles, it falls flat, and it loses its superposition.
And in quantum mechanics, this crash is called decoherence.
Yes, decoherence.
Which is why quantum computers today look like giant steampunk chandeliers inside vacuum tubes, and they have to be supercooled to nearly absolute zero. They're trying to freeze out all the environmental noise so the coins can keep spinning.
That's it. Any thermal energy is literal physical jitter at the atomic level. But the Grok analysis proposes a groundbreaking theoretical model here using the antenna.
How does the antenna help?
Because the triaural antenna generates a perfectly balanced, continuously cycling toroid field, it could act as a geometric shield.
A shield.
Yeah, by placing qubits within the center of this field, the swirling energy acts like an active shock absorber. It harmonizes the chaotic quantum fluctuations in the immediate environment.
Oh, wow. It functions almost like active noise-canceling headphones, but for reality itself.
That is a great way to put it.
It listens to the chaotic noise of the room and feeds a perfectly tuned opposing geometric field back at it, keeping the qubits protected and coherent at much higher temperatures.
Yes, and if you can maintain quantum coherence without needing to cool the system to minus 273 degrees Celsius, you completely alter the timeline for making the quantum internet a commercial reality.
I follow the logic there. But I have to push back on the next section of the analysis because the documents venture into territory that sounds highly controversial.
You mean the energy harvesting?
Yeah. There are multiple references to free energy, the Casimir effect, and physicist Paul Dirac. Are the sources genuinely suggesting that this triaural shape can pull electricity out of nowhere?
Well, we have to look at this through the lens of established quantum models and keep it objective. In classical physics, a vacuum is completely empty space.
Right.
But Paul Dirac and modern quantum field theory proved that a vacuum is actually a boiling ocean of energy. It is constantly creating and destroying temporary virtual particles. This is observable through the Casimir effect, where two uncharged plates placed microscopically close together in a vacuum will actually be pushed together by the pressure of these quantum fluctuations.
So the vacuum of space has a baseline hum of energy, often called zero-point energy.
Yes. And the theoretical model in the documents suggests that the triaural antenna's highly specific toroid geometry might act as an open thermodynamic system.
Okay, what does that mean in practice?
Think of the vacuum's energy like a steady wind. The antenna is proposing a new shape for a sail. By matching the precise resonant frequencies of the quantum vacuum, the continuous feedback loop of the antenna might be able to tap into that ambient energy, harvesting it to create a self-sustaining cycle.
But does the math in these documents support this? Are we looking at the blueprint that replaces the global electrical grid?
It is crucial to separate the theoretical mathematics from current engineering realities.
Fair enough.
The text explicitly notes that right now, our ability to convert mechanical acoustic vibrations into electrical energy using piezoelectric materials has an efficiency rate of roughly 10 to 30%.
Oh, so pretty low.
Yeah, you would need unimaginably massive arrays of these antennas to power a city. So no, this isn't replacing the grid tomorrow.
Got it.
However, mathematically, the principle of using a geometrically locked, decentralized loop to tap into ambient zero-point resonance does hold up within the AI's theoretical models. It's a horizon technology.
It's the blueprint, even if we don't have the manufacturing tools to build it yet. But let's bring this all the way back down from the quantum vacuum to something deeply personal.
The biology section.
Yes. The scaling is what gets me. We started in a puddle of water, moved to silicon microchips, and then zoomed all the way down to subatomic space. But the sources circle back to biology. What happens if you take a living, breathing human being and place them inside this triaural field?
This is where physics, bioacoustics, and quantum biology intersect. It requires us to remember the very first experiment we discussed, the tuning fork creating geometric whirlpools in the water.
Right, because humans are water.
Exactly. The human body is approximately 60 to 70% water. Our cells are essentially tiny balloons filled with conductive fluid.
So we are basically walking, talking acoustic receivers.
Biologically, this mechanism is called mechanotransduction. It's a well-documented process where cells feel mechanical pressure or vibration and translate that physical force into chemical responses.
Oh, like how exercise works.
Right, it's the same reason your bone density increases when you lift weights, or how the tiny hairs inside your ear allow you to hear. The AI analysis applies this to the triaural field.
Okay.
If a human is exposed to this toroid energy, the documents theorize it could induce cymatic microcurrents directly into our cellular fluid, our lymph system, and our bloodstream.
So if this field is vibrating at specific frequencies, and the text highlights 528 hertz, or the 7.83 hertz Schumann resonance, which is the Earth's natural background frequency, my cells are physically feeling that geometric whirlpool.
Yes, and the proposed model suggests this could have profound physiological effects.
Like what?
By inducing these highly structured microcurrents, the field could increase cellular membrane fluidity. That makes it easier for your cells to absorb vital nutrients and flush out toxic waste.
Wow.
Furthermore, it could physically stimulate the mitochondria, the powerhouses of the cell, potentially increasing the production of ATP, which is the literal chemical energy your body runs on.
I want to tread very carefully here, though,
Oh, absolutely.
because the documents reference researchers like Masaru Emoto, who popularized the idea that water has memory and reacts to human emotion, and Peter Gariev, who explored healing DNA through sound. I want to make sure we aren't validating fringe pseudoscience or pitching this geometry as a magical medical device.
It is imperative that we maintain absolute objectivity regarding these claims. We are reviewing a theoretical framework proposed by the AI analysis, not clinical medical data.
Right.
The text explores how the triaural field acts as a highly coherent force. In a biophysical sense, our bodies generate an immense amount of chaotic electrical and acoustic noise simply from daily stress, poor diet, and environmental toxins.
Okay, that makes sense.
The hypothesis is that the perfect 120-degree toroid field could act like a master metronome.
It overwhelms the chaotic noise of the body by offering a louder, perfectly structured rhythm for the cells to follow.
Yes. In physics, that's called entrainment. By entraining the body's chaotic rhythms to this stable geometric field, the theoretical model suggests it could lower the production of cortisol.
Just stress hormone.
Right, the primary stress hormone. And it could induce alpha and theta brainwave states, which neurologists associate with deep relaxation and cellular repair.
And the document also attempts to connect this directly to consciousness
Yeah.
itself, mentioning the Orchor theory.
That is perhaps the most provocative model in the entire stack.
What is Orchor?
ORCH-R stands for Orchestrated Objective Reduction. It's a theory developed by Nobel laureate physicist Roger Penrose and anesthesiologist Stuart Hameroff.
An anesthesiologist.
Yeah, quite the duo. They propose that consciousness isn't just a byproduct of chemical synapses firing, but that it actually originates from quantum vibrations happening inside microscopic structures in our brain cells called microtubules.
So our brains are essentially organic quantum computers.
That is their hypothesis. And if we connect the dots of the Grok analysis we established earlier, that the triaural field can theoretically act as a shield to stabilize delicate qubits in a silicon quantum computer,
Oh, I see where this is going.
the documents propose that if human consciousness relies on quantum coherence in our brain's microtubules, stepping into a triaural field might physically stabilize and amplify our own consciousness.
It's the ultimate convergence of geometry, physics, and the mind. That is an astonishing concept to try and wrap your head around, but it brings a tremendous elegance to everything we've discussed today. Let's look at the totality of this journey. We started with the simplest possible action, breaking away from a binary 180-degree straight line.
Right.
By shifting to a three-pronged, 120-degree geometry, we unlocked a self-sustaining toroid field.
And we watched that single structural truth scale across every layer of reality. It organizes water into perfect hexagonal fractals. It can be engineered into solid silicon to create hack-proof, dead zone-free electromagnetic antennas.
Yeah.
It has the theoretical potential to shield fragile quantum computers from thermal chaos and perhaps act as the key to harvesting ambient zero-point energy from the vacuum of space.
And finally, because we are physical creatures made of conductive fluid, that exact same geometry could theoretically act as a tuning fork for our own biology, harmonizing the chaotic noise of our cells and potentially even stabilizing the quantum architecture of our minds.
The profound takeaway from reviewing these documents is that shape is not passive. Geometry is an active, driving force in the universe.
Yeah.
The straight lines and binary systems we've used to build the modern world might have just been the scaffolding. By understanding complex nonlinear geometries like the 120-degree triaural wave, we are finding the shortcuts to the invisible mechanics that govern reality itself.
It really shifts your perspective.
Yeah.
The universe doesn't seem to favor straight lines, it favors the whirlpool.
And it is a deeply interconnected, mathematically beautiful whirlpool.
I want to leave you with a final thought to mull over as you go about your day. We've seen how this 120-degree triaural shape can theoretically stabilize quantum fields, protect delicate information, and filter out the chaos of random noise just by maintaining a perfect resonant loop. The next time you walk outside, take a look at the natural world around you. Look at the branching of tree roots, the structural veins of a leaf, and even the intricate geometry of your own body. If the shape of a thing fundamentally dictates how energy flows through it, what kind of frequencies are you naturally tuned to receive today? Keep diving deep.